Day two, additional topics of trigonometry. Law of sines we introduced yesterday. Um, we took care of both of these. Um, where's my pen? Law of sines and oblique triangles. The ambiguous case today, area of triangles, and we are going to apply them. So today we're going to find the area of an oblique triangle. Oblique means that we don't have a right triangle, nor do we have the height. Now, the nice part is that with an oblique triangle, we can always draw in the height and go from there. So if we A and B and C, call that the height, we know that area equals 1/2 base times height. So in order to find the height, we are going to look at the sine of A over B, right? The sine of A equals H over B. And then if we come from this side, this is lowercase a, we've got the sine of B equals H over A. And notice that if we solve for H in both these equations, we have a system of equations here, right? We get H equals sine of, that's not true, H equals B sine A, or H equals A sine B. So we know this side here is side C, right? If we plug this in place of H, we can get 1/2 the base of C sine, it should be B sine A, sorry about that. This is B sine A, or if we'd gone from the other side, we can go 1/2 the base of C and A sine B. Now, notice the connections here. This one says 1/2 BC sine A. That's exactly what we have here. This one says 1/2 AB sine C, which we didn't come up with. This one says 1/2 AC sine B. Notice 1/2 CA sine B, same thing. We could rearrange this and still come up with this. So now, you guys, the idea to this is that if you're working with, say, angle A, we are looking at this formula or this formula, and they're saying we got to have side B and side C. So notice that you need the two adjacent sides to the angle. So this formula just simply is 1/2 the two adjacent sides sine of the included angle. Is one way to look at it. You don't necessarily need to memorize all three forms. Not that you need to memorize them anyway. You'll have them. So find the area of a triangle having two sides of length 8 meters and 12 meters and the included angle. Notice that that's what they're talking about, rounded to the nearest meter. Now again, you could easily draw this picture 135-degree angle. We know that this one side is going to be 8, one side is 12 meters, and we're supposed to find the area. Well, the nice part about this is that the area is 1/2 BC sine A. Obviously, this will be A, this will be B and C. The two sides will be B and C. So we just plug that in, 1/2 times 8 times 12 sine of A, and let's plug that into a calculator. Okay, so you're going to a calculator. I'm going to use Desmos just because it makes it easy to display. Now, you guys, one of the things you got to remember is you got to make sure that your calculator is in degree mode now. If you're going to use Desmos, you go up here and you look for radians and degrees. I was in radians. That would have given me a wrong answer. As long as I'm in degree mode now, I can come over here and I can just plug in 1/2, 1.5 times 8 times 12 times the sine of 135. And notice that it automatically gives you the answer as you're going, 33.9 degrees equals, or it's not 30, not degrees, but 33.9 units squared, but they said round to the nearest square meter, so that's actually going to be 34 meters squared. Pretty straightforward. I like these. These aren't that bad. Then we get to the application problems. And the application problems is where we usually have trouble. Um, Again, draw pictures. Do not be afraid to use plenty of scratch paper and draw large pictures. If you draw them small, we tend to have trouble. All right, so 2 lookout stations are 13 miles apart, with station B directly east of station A. So I'm going to start, I'm just going to draw my crosshairs right here. Here's station A. We got north, south, right, east, and west. So we know that station B is over here. And again, you might want to draw the crosshairs through that, but you might want to draw it so that it's actually through it, not around it. All right, and we know that that's 13 miles. Both stations spot a fire with a bearing, the bearing of the fire from station A is north 35 degrees east. Well, I know from the north we're going this direction. 35 degrees east is this direction. That's 35 right there. And I'm going to try to write that so we can read that. 35 degrees. That's that right there. Okay. And the bearing of the fire from fire station B is north 49 degrees west. Okay, 49 is a little bit more than 45. So that's going to go this direction. And that's 49. Now notice what happens is if these two keep going, that they're going to intersect and you're going to end up with the fire right there. Okay? How far to the nearest 1/10 of a mile is the fire from station B? All right, so pay attention to what they're asking. They're asking for the fire from station B. So we need this distance right there. Okay? So let's go ahead and fill in things we know. We're working with the law of sines. Remember, sine of A over A equals sine of B over B equals sine of C over C. And you may not need the whole thing, but it's available clearly. So let's fill in what we know. If A is 35, we don't want that one. We wanted this one. Remember, we're looking for D here, right? So for B, this angle here, if we go 180, not 180 though. How about 40? How about 90 minus 49 makes that 41 degrees, right? Okay, so I now have all kinds of sides. I guess I probably should continue. I don't necessarily. Yeah, I probably should. Let's keep going. If this is 35, then this is going to be 55, correct? Let's go ahead and fill in what we know. So sine of 55 over D, we might have called that A. I just called it D for distance, equals sine of 41 over, what do we got? 41 over, we'll call it lowercase b, equals sine of C over 13. Oh, look at that. We don't have a full ratio somewhere. But notice that I have 2 out of the 3 angles. I should be able to plug that into a calculator and find out that our angle C is equal to 84. So up here, we're going to replace C with 84. I now have that completed ratio, and you know that I'm trying to find D, right? So we didn't need everything, but now I can cross multiply. 13 sine 55 is equal to D sine 84. We need to isolate D. We know D is going to equal 13 sine 55 divided by sine of 84. And now we're going to plug that into a calculator. And we get D equals 10.7 miles. And that makes a little bit of sense. If we had drawn our triangle maybe a little more accurately, we could recognize that. All right.